Chris, do you have a real name?
You can call me Theo.
Theo. Okay. Very nice to
And
meet you. I've seen you in Joshy's work hours, and I knew y'all were going to meet this morning. And I'm glad. It looks like I haven't missed it, so I'm glad I got here in time.
yeah, I
Well,
haven't got started yet.
pre-recording, we were just getting to know each other, and I'm excited because Theo is interested in many of the same things I am.
Well, I was certainly impressed by your skills at Rolang. Yesterday, when was it we saw that? Yesterday.
Yes.
How long have you been working with Rolang?
A few months, I guess. Started diving into it around the time of the last DevCon in Denver.
That's amazing. I've been involved with the project for a couple of years, and I'm not nearly where you are now. So, well done. Are you a professional programmer?
So to speak. I'm doing less programming these days than I used to. I'd call myself a system designer.
I see.
But,
Yeah, I'm a retired educator with some experience in computer science back in the 80s. I did assembly language and C language before there was even C++, but now I'm getting back into it with the interest in distributed applications and crypto.
Awesome. Well, I think Rolang is an incredible language to get into. I'm trying to teach it to a couple of my colleagues who have backgrounds in like philosophy and logic. And I don't think that not having a programming background or not having a recent programming background really puts you at a disadvantage, because the patterns are completely different and new. And
I agree with you, and I'm so glad to hear it coming from someone who has more experience as a professional in the field say that. But that's what I've suspected as well.
Yeah, and it's a lot of fun. I mean, I've been looking for a good language for describing open systems for a long time, and Erlang, I think, does a pretty good job, or just actor model in general. But there's limitations with that as well. And I don't know if you've ever tried to build something that's like open and large scale on Ethereum, but it doesn't work particularly well.
Yeah, I can imagine. It's one of those things that I would rather not even have to worry about all the concerns that one would have in trying to build that on Ethereum.
Yeah. Well, it's interesting because the thing that makes it kind of challenging on Ethereum is also what makes it so much different than Rolang and RChain, because there's in Ethereum there's a native concept of an actor, right? Or an actor is something outside of the system that expresses agency, and that means that the contracts themselves have to be aware of that, which is why all of the contracts in Ethereum use access control lists to manage authority. So if you have like ERC20 contract or something, you say this is the owner and this person has access to this balance, so therefore they can change it, that kind of thing. And it just gets very complicated once you start thinking of composition and open systems and stuff. So that's kind of what makes the Rolang RChain wallet question kind of hairy and tricky, but it's also what gives it so much potential and power. So
yeah, the access control list is the antithesis of the capabilities model. Okay, so we definitely need to get are wanting to get away from that, and
yeah,
we're using the capabilities model with RChain. And
so on which note, I had proposed to Jim that we go through a couple of contracts during this session. I think the key value store might be worthwhile because it introduces a couple of patterns in a way that sort of makes more sense than the forwarder. And then There's a couple of examples of sort of simple forwarders in the tutorial in the main Rolang sub repo. But then there's also the forwarder that I wrote that's a little more wonky, but incorporates the same ideas.
And if we have time, you were interested in working on which project was that again? Was it the RChain or the browser?
Both, actually. Yeah. So just I guess a little bit of background. My project is with a group, not really a company, collective maybe, called Economic Space Agency, and the project that I'm principally focused on is called Space, and it's I think like a grammar for programming synthetic organization. And I guess similar to Jim, your project, it's blockchain agnostic, or really it's everything agnostic. It's just it's a pattern language, so it includes a way of reasoning about process and context. And so, if that process happens to be the Bitcoin blockchain, and the context happens to be proof of work, then that's one thing. If it happens to be organization and a human, that's another. If it happens to be the U.S. Mint and dollar, that's another. So it's all sort of the same thing, but certainly having the ability of programmable trust and synthetic trust that blockchain networks and systems like that provide makes it a lot.
It sounds like this is very much in line with the social ledger.
I'm not familiar with the social ledger.
Well, okay, the social ledger is out there. It's everything about any of our interactions in the ledger of what we do and say ourselves, that things, and then in our interactions we have joint ownership of the ledger of those interactions with people and other social objects like documents or whatever. So the social ledger project builds a skeleton of the ledger and aims to provide for exposing the ledger according to the rules of the individual, the team, the domain, the organization, and how that information is exposed outside the organization, the team, the domain, the team, and the individuals, down to the activity. Okay, what the activities that people are involved with. And what the current prototype does is it provides a visualization of that.
Interesting.
In a holographic diagram. And so we have a prototype. We're running a trial that is being applied. We've experimented with it. Digital Life Collective is going to go live with the prototype as we're designing Social Ledger 2.0. And one of my mandates is to bring the social ledger into RChain. And we have a channel in CoLab with no activity. And, I can't really, well, there's two things that I have to do. One thing is I have to move RChain into their own database, because right now they're in a Holonic chart with 11 other databases, and there's performances, communities, and there's potential performance implications, and there's control implications. We want the RChain instance of the social ledger to evolve independently of anyone else. We want to be able to connect them, but once you have the data, we can do that. Okay. Yeah. And then we have the network map in the visual life of all the decentralized organizations and tools, which kind of form the global connections of all the social ledgers in the decentralization space, anyway. Gary is one of the prime proponents of the social ledger. Why don't you give him your 2 cents on what it is?
Yeah, the way I see it is it's sort of a layer on top of one of these Slack type platforms. It currently resides on Mattermost. Are you familiar with Mattermost?
Mm-hmm.
Yeah, we because of some of the peculiarities of the way Mattermost handles Markdown, it turned out to be a better place to start. That is my understanding of why we ended up deploying it on Mattermost first. But it's really a better way to bring the work into the community, and I see it as a way of jump starting this collaborative work out loud, mutually cyclic sort of learning, building, playing thing. Just to show you something. Am I on? Okay, I'm sharing.
Mm-hmm.
If we go over to Mattermost, for instance, here is one of our Mattermost social ledger platforms. Here's our RChain social ledger platform, and you're familiar with Mattermost. Here are channels down the left side. We've got the general channel where everybody lands when they join this Mattermost, and there is an introduction to the social ledger there on the screen.
Yeah, well, let's just show them team and activities, and let's get. We need to get into the meat of this.
Okay, but anyway, you use slash commands. At this point in time, we have to use slash commands. We're going to get away from that. But we say dig A, and we get the meta menu for the channel, and it gives us all the pertinent links and actions and norms that we can propose, and they're all available to us on a per channel basis.
Yeah, it's like pinning an item to a channel, but it's cooperative, and it's categorized. You have your contracts, you have your norms, you have your goals, you have your.
So people could come in and claim commitment to these things, and they give it this sort of.
So we know who's engaged in what activities, and then we.
So there's that, and
you click outside. You can zoom out. Zoom out. There you go.
So these are the activities on the RChain platform.
That's the channel. That was the channel. The channel was in the domain, and then the domain is in.
We could go to these other. There's our Dig Life domain, DiviDAO, Bring Your Own ID. All these different domains in here show different level of activities, and you can zoom in a little bit to get investigate this one. This is the outreach trial and the different things that people have proposed in there. And I didn't mean to go there, but I'm going to get out of that now. That's about all I want to say. Do you have any questions before we start your demo, though?
Yeah. So there's some state stored somewhere, and the interface to that is through the Mattermost.
Jim, that's a question for you.
Yeah, we're using Markdown, and so we need a platform that supports Markdown right now.
Right, but all Mattermost is the interface to whatever the system is. That
Right. We also have another interface, a dashboard. We can show you that later.
But these items that we're seeing right now, those are all created or generated from the Mattermost interface, or is this actually?
Yes. We create them. I'm creating a link for you here in this menu, and so this is just standard HTML Markdown. Yeah. I'm using here on this line, and then I'll put the link in the the HTTPS here, and then when I hit enter, it will get added to this list you see up here.
Yeah.
We create everything right here at the command line in the channel. All users can do this. And we can look at things like members. We say dig members. These are members of this channel. Let's go out to a different one. Let's go to this. Find one that's got some members. So here are the members of this channel: Jim Scarver, Joachim, Casey, Kit Blake, Lapin 7, myself, and Tony Priska. And we have roles, and these are per channel. These are this channel only. We have a guide, scribe, actors, and then they can be novices, apprentices, regulars, so on and so forth. Let's see, what else can we do here? We can go dig. We could just do a dig command, and we get the this is the system-wide menu you get with the dig command. And then we can do dig.
Flash dig help tells you all the things you can do. Okay, let me show something quick here. I'm going to steal it.
Go.
We have the Mattermost interface, and we have the dashboard. So this is the same channel in the dashboard where it can show. It shows my activity in each of the things. AI bot development. Okay, it shows I have 0% commitment to this. I'm providing 0% commitment to this item. Okay, and I can control it. I can archive it. I can delete it. I can change my level of engagement.
And is this meant to be, it seems like there's a couple of different systems that are being developed or in use to manage all the activities. Yeah.
Well, this just shows that Mattermost isn't the only interface. I can add activities here. I can look at the domains. I can zoom in on channels.
Interesting.
And also the holonic graph is somewhat interactive. It'll take you to the channel. It could do more. The important thing is the data. There's all kinds of visualizations. The other visualization would be the network map.
Mm.
Oh, I'm not showing my screen?
Yeah, you were showing it most of the time. You just stopped.
Oh, okay.
Now, in terms of keeping it in sync with, for example, the bounty program, or what is it, RTime, like there's a number of different things. Like if one wanted to see the state of the RChain kind of community ecosystem, is there one view of that, or is there an interest in having those all be coordinated, synchronized, using the same protocol, so that there's not separate views that have to be kept in sync? Or
Jim, you're muted.
I'm not sure what you mean there. I mean, you can view the system. We don't have it. Oh, what did I do? /dig team. do that one. If I look at the network graph here, okay, we can see, and this is one of the problems here. This has gotten way too busy.
Way too busy.
We can create a holonic diagram from the perspective of any individual. So it's a holonic structure, which, you know, from the top down, is shown by the holonic view, but from the bottom up, it's holographic. It's a different hierarchy from every person is this.
Oh, this is HoloChain, right?
Is the top of some hierarchy. They are in control of something.
Well, I guess my question was that there's the idea here is that you have some representation of the interactions within an ecosystem or a community, and that there's what is the state that's being presented there and that's being interfaced with in the Mattermost, because that state is different than, for example, the social interactions that are happening in Discord and the social interactions that are happening on the GitHub bounty thing, right? Or
You're muted, Jim.
The actual ledger is mostly separate. I mean, certainly it has its logs, and the actions that people take in the ledger are recorded in the event log, whatever. But most of it is the actual conversation in the channels, or
right.
the work in the document that's being pointed to. We're just creating a skeleton to connect various social ledger aspects. Sort of like you were talking about with Bitcoin ledger and this thing, and so this is a skeleton which seems very compatible with what you're doing in terms of how we want to relate these things. It sounds like we could apply your work directly to this.
Could be, certainly. I think especially if we turn more towards HoloChain, I think it's a pretty good application for that, because you have that kind of the ledger just becomes all of the interactions between people in different channels and just kind of emerges.
Well, we're putting this on RChain.
Yeah, right.
Okay, but you know, but it certainly can be a skeleton for stuff on HoloChain or anything. I mean, right now it's a skeleton primarily for Mattermost, and then when people put in issues and they put a link to GitHub in there, then the GitHub becomes part of that ledger. Okay, right. Click on it, you go to the discussion, you participate. Okay, and one of the things we're going toward is making everything more automatic, so that you don't have to, so that what you do is reflected without taking any action in the ledger. You know, you don't have to know the social ledger exists basically to be part in it, of it.
Makes a lot of sense.
But, you know, and this is why privacy and people owning their information is so important.
Absolutely.
You know, we need to obey their rules. You know, some people, it's fine for their email address to be disclosed, other people no. And that's why this work that you're doing on the forwarder is important.
Yeah, well, on that I have a couple of different patterns that I think will be more practical. I haven't written up yet. So if I want to learn more about social ledgers, the best place to look at the social ledger channel in Discord, or is there?
Look at the pinned items.
Pinned items.
Although there are some missing things, the social ledger 2 effort is kind of slow right now. It has its own Mattermost instance that Joachim is sort of the leader of the social ledger project. He developed almost all of the existing code, and is working on the new, the beginnings of the code for the social ledger 2.0, which now he's working on a card interface primarily.
Card interface.
It's cards where you have, basically you you have cards that you share with other people. You have spaces where you're working. You may put a chat card in there. You may put, that's the user interface. It's user interface agnostic, it would be accessible to anyone for any purpose with GraphQL, which gives us the strongly typed nodes that correspond well with structures on our node or our RChain.
Excellent. Well, check it out. Thank you for sharing. So I could probably stay until, we started a bit late, I could probably stay until 4:15 my time. 10:15 my time. If you want to go back to the code to start reviewing that, and then if we need to finish it up another time, we can start another session then.
I think I'm going to end the recording and restart, since we were talking. The first part was on the social ledger.
No, it's not.
Okay, part two. First part was on the social ledger. Now we're getting back to tell us about it, Theo.
Rolling.
Yeah. I've got too much stuff open. I'm just trying to track it down right now. Yeah. So the proposal was to go over a couple of different patterns. One of them being the key value store, which uses this, I think, pretty useful kind of pattern. And the idea is to try to explore patterns that don't rely on kind of the Scala data structures to get things like a key value store or other sorts of data structures. And then also to look at the implementation of forwarder, which uses a similar kind of pattern. Okay, so KV store, the interface uses, first off, is this legible by everyone?
That's better.
Okay, cool. I talked a little bit about the patterns that I use, but just to summarize, capital is a constructor. So here we're doing a new KV store constructor. C is always in continuation. Everything always ends in continuation. Introduce a new scope, and this is the scope that's going to be written to, or basically you register the interface around this scope, and then you export the scope at the end. Always explicitly call out what is being exported from the object. This hasn't really been talked about much, but when you're doing a pattern of basically creating interfaces around this scope, you always only want to release the right aspect of the interface, because then you can hijack the API if someone gets access to the object. So if you're doing a publicly available object, you always want to only expose that, or there's sort of another pattern where you only expose the read. Just a good comment. So the general pattern is that we're creating an interface that's using the tuples. So here we have a tuple made out of the scope and a forgeable name, in this case put, patch, get, delete, and exists. We register each one of those handlers, and then at the end we export out what we defined in the beginning, which is just this write interface over the scope.
Yeah, that's a lot. Questions?
Yes, I have a question, and I'm sorry I put it off this long. Let's go back to the very top.
Mm-hmm.
When you say C is a continuation, can you say that in some other words?
Yeah. Are you familiar with JavaScript? Or it's a style called continuation passing style, where basically you have this every time you invoke a function, it's sort of an asynchronous programming paradigm. You always pass it kind of the return, right? So it allows you to create this style of every single function having being saturated with continuations, such that you can have this chain that doesn't rely on any one of those steps to be completed before the other ones can succeed. You're always basically passing the promise from one to the other. And then as soon as sort of enough are ready, it'll kind of collapse and they'll all call each other. So the promise pattern in JavaScript is pretty widely used. And in that, you basically say, do this function, and then when it completes, send the result to here. And that's how you avoid the huge, big nested structures where you have like callback, 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 waiting for things to finish. And instead you could say, when this finishes, hit the value and put it here. And then you know that this thing represents a promise to the result of some other function. And so it allows you to kind of write asynchronous code in a sort of asynchronous way.
Okay, thank you. That helps a lot. I have understood that in other context, but this is the first time I've heard it come from someone who's actually programming Rolang rather than writing the programs that created the Rolang and compiler. So I'm having to do a bit of translation. But to answer your question, no, I'm not familiar with hardly any programming language. So expect strange questions coming from me when I hear words that might be familiar from other programmers.
Yeah, you might remember from our JavaScript work where we would call a function like read a disk file or get it from a URL. And the last argument was what we wanted to do when we got that result. That's the same thing. You've also seen the ACK pattern, which is really the same thing. When the method is done, it writes to the ACK, so that.
Oh yes. Okay, good. Okay, but yes, and it's starting to come together for me. I wanted to get that out of my system before we went too much further into it, but that helps.
Sure. Yeah, no, glad you asked. Also, perhaps sort of related is like piping, right? So you say, here's this thing, and then whatever the result is, it gets piped in this other thing. And so it's kind of something. You think of the continuation as, what do you pipe this into after you're done? Except instead of having to sort of do it one by one by one, where you get these huge nested things, you can say, do this, and then you can have say a collection of promises, and say when all of these things resolve, which is what a join is, like when you do like for this from this, semicolon, this for this, semicolon, this for this. It's a join across a bunch of different threads. And then you can, anyway. Okay, so we can look first at this. So this put, and this takes a key and a value and a continuation. So get store is basically where I'm putting the state. And I initialize get store with nil. There's nothing in there. And that's important because then when I ask for the store, I get back nil, or I get back. Really what store is a process that's stored on the get store channel. But then the pattern is basically that this is a process composed of many parallel processes. That's all grouped as one process. And so all the store is this string of parallel processes that's getting stored at one address, and you pull it and you say, does something match that? And then you stick it back. And so in this case, what we're doing is we're putting a value onto that store. So if this starts off as nil, that means store is nil, which will match this. Then what we're doing is we're putting whatever store is, which is nil, back on, right? So after this, let's say we're doing store, okay. So if we were doing this, see, we're adding the key is my val, the value is 42. Then what this would store is nil, because that's what was already in the store. And and 42. And so, oh, this is like this. Eventually you end up with you know, let's say these are all different things, and they don't have to be strings. This can be secret key, and this can be some, right? You can store any kind of arbitrary process inside of the value structure. But what this means is that all of these are stored in the store. So anytime you say get the store, let's say we call put my val 42 again. In that case, the first thing we're doing is we're saying, does this key already exist? So what this pattern is doing right here is it's saying, okay, we have this process that is a group of parallel processes, right? And what we're saying is, are any of these parallel processes of the form that it is some key being sent some process? And so in our case, this key would be my val, and the process would be 42. And then this part right here says, and then something else, right? Which this would match with nil. So if there's only my val 42 stored here, then that's what it'll pick up. But it could be any number of other parallel processes, again, because a process is just composed of processes. And so you can have a million processes under this underscore, or you can have none, and it'll still match. And so this is just doing a check right now that says that does the key already exist in the store? Now, if instead we were trying to, let's say, just get the key, right? So we submit my val or my var. We retrieve the store. Because we're not modifying the store, we immediately put the object back onto the get store. And then, so we talked about this pattern yesterday, right? Where you're not shadowing, you're explicitly saying, I'm looking for something that is sending a message to this key. But value is unbound, which means that we can capture the value in this pattern, and then we return the value to the continuation. If we don't, we return an error that says the key does not exist. So this is a pattern that I use. It actually turns out to be very useful for data structures, because then sort of the input is exactly the same as the output. If that makes sense. Like what you're matching against is exactly the same as what you're sending. And so if you're writing interfaces, you can kind of just like copy paste the definition from one. Probably have some examples somewhere here. But also for testing, it's sort of like they're kind of like structs a little bit. And so in this case, let's say you have your for response right, and then you say match, and if it matches, then we know how to handle our error. And if it's not, this is the value, and we get to value kind of thing. And so you can build up pretty complex sort of data structures just by using this. And I like this a lot because it doesn't rely on, I mean, it uses the strings, but otherwise it doesn't really rely on the Scala data structures. And it's just, composing out of processes. So
I'm a little confused. Where do we get key?
Oh, sorry, I skipped over a few steps. Imagine this is outside of this scope, and imagine I was just doing I mean, this is just like a contrived example to show how you would handle the response. You wouldn't actually stick this in here, but if this were invoking this, is how you would handle the error. So,
yeah,
you put it down here, right? I don't know.
Awesome.
Okay. And so, yeah, that's kind of the basic pattern, but just wanted to show that as a way of, there's another pattern I was using before, which is similar to this, except you have, let's say KV store were just a read-only channel. And so you would write to that, let's say it was like a registry. And then you can check the registry by just reading from it and matching here. So the difference is, like, let's say this was like this. Right? It's like that sort of. The difference is that this isn't guaranteed to return. And so the problem this is trying to solve is how do you have something that's like a registry, that's like a data store, that will always return if the key doesn't exist. Because if you're just reading from the channel and you're hoping to match something, it's a pretty interesting pattern, but it doesn't always return. You can often be left just hanging, not really knowing if you're waiting on the network or if the key doesn't exist, and you won't get a return until it does. So that's kind of how we got to this, and there's some pretty complex or interesting things that you can do using this as a base. So just want to touch on it, but the basic idea is this idea that you're storing, like, the state is just a bunch of parallel processes that then you're pulling off, you're matching against, and you're sticking back on. So. We just look briefly, REST or patch is just like put, except it just basically erases the key and then adds a new one. And then delete matches the key but doesn't store it, and it just stores REST. And then exists just checks for the key. So, and then maybe we can briefly go over forwarder. We have time. It's a pretty short contract. Not that one, this one. The idea is that you create something that wraps a process, and you're basically generating like proxy tokens for that process. So the state, just as we had in the KV store, is the list of all the valid tokens that you have. And so whenever you're generating a new token, you're just appending it to that list. So you see you get valid tokens, and yeah, so yeah, basically this is something that you initialize by sending in a process. This process could be like the car that we were talking about, or the process could be a mint, or whatever you want. You have to have some information about what the interface is. So this process expects interface where it's passed a method and a message and a continuation. But you can kind of do that however you want. And then it allows you to create tokens where every token is passed in a series of a series of strings, or a collection of strings. And those are the allowed methods. Like here's you're allowed get, or let's say you have something that's a registry, right? And it has a get method and a set method, or the KV store that we were just looking at. So what if we wanted to only allow people to have access to the get, right? So you would say the allowed method is get, and that's it. Then you generate a new token, which you could think of as like an OAuth token or a bearer token that encodes certain rights.
Is it going to be a list, or is it par? Or
Is what?
are the method names in a list, or are they in parallel?
In parallel, like this. So here's an example where you have a card that has unlock, start, and unlock glove compartment. And so you create a valet token that has access to the unlock and the start, and you create an owner token that has access to the unlock, start, and open glove compartment. And you could write this using a list very easily. I just am using pattern matching for everything now, so everything looks like appropriate nail. And how it would work is that when you invoke, so this token is what you're given as a proxy for the object. You invoke it with the open glove compartment, and then it matches the method against allowed method, right? So if allowed method is a bunch of strings, then if your string is one of those strings, then it lets it through. Otherwise, it doesn't. And it does a similar thing for the matching the token, right? So if valid tokens is a bunch of parallel token objects, if your token is one of those objects, then you are allowed through. There's also the revoke. All the revoke does is take your token off the list, and then it's no longer in the list, so it's no longer valid. And then, yeah, so pretty straightforward, but this has the attenuation and the revoking. Just kind of a way of highlighting this pattern that I'm a fan of kind of storing state and then matching against the state when you want to access part of it.
Now, is there, how can we generalize this by passing it a rule, which may be a list of allowed processes?
Yeah, so what I'd like to do is have it be basically a pattern. And what makes it a little tricky is that you have to know the arity of what you're invoking. So this, for example, has 3 processes that are passed to it. But you can easily do a token that has a definition that is 1, that is 2, that is 3 for all the different patterns. And then what you would do is you would have, like, really what this does is just saying, here's the pattern that you match against the first invocation, or the first process. Here's the pattern that you match against the second process, right? And the pattern that you're matching is just is this, right? And so the ideal version of this is that you would be able to sort of wrap an interface and say, here are the kinds of messages that can be passed through, which is sort of what this is doing, but it's assuming something about the structure. And so the generic version would just have, like, here's the pattern, and then you're matching against whatever you get. And then it would be much more like a cooler way of writing this would be,
I guess you can already put any pattern in that you want to match in the token. You can give multiple patterns, right? And
yeah,
you just happen to be using it with the string as the pattern, but it really could be any pattern.
Yeah, good. But yeah, in principle, this is what you would do, and then you'd overload this for like this. And so you'd have separate definitions for the different ways of invoking the function, or each one is just looking at the pattern. And then whenever you're creating a token, you're saying this token can invoke this pattern or this process with these sets of patterns. A way of perhaps simplifying this is using like a role thing. So you can basically, a role is a pattern, and you can specify, here's the role that lets you do access the scope of an object. And then all you're doing is you're creating tokens associated with roles. And then you can just revoke the tokens if you want, but, or you can assign multiple roles to a token kind of thing, and have that sort of like a role capability based management. Yeah, so I haven't thought or worked too much on this. I put it together before the call yesterday. So if there's specific use cases that you're interested in, I can maybe put something together a little more robust.
So I guess this might be out of scope, but is there a way to get it to do all the patterns that match? Rather than just the first one?
All the patterns, like I want to create a token that lets you do anything.
No, that yeah, I'm thinking that of.
So if you were to do like
yeah, never. I guess
string. I mean, you want to be able to do something like this, and one of the challenges is I don't really know how possible it is to pass into store pattern definitions. So I mean, it'd be nice to do something like this, but I don't think it will work. Like where you can actually pass in the pattern that it will match on.
Isn't the pattern a process?
I don't know. I mean, so processes don't have any holes in them where patterns can, and like you can't send an underscore, for example. It's not a process. I think patterns are distinct from processes, but I don't know. Yeah, I'm pretty sure you can only use them in the match or in the for, or the destructuring or the matching operators. So, I mean, I'm quite certain that there's other kind of creative ways of doing the same thing, but this at least I don't think will work. Anyway, I hope that wasn't too confusing. I'm going to be continuing with this repo, cleaning things up and adding some more patterns. Happy to go through whenever. I've got to head off now, but happy to stick around another 5 or so minutes if you want to wrap up or ask questions. Oh, and here's like a simple forwarder, which is like revoking. This one doesn't do attenuation, and it doesn't do tokens. So it's just a single forwarder.
Great stuff. This is awesome, Theo. Do we know Anson? Can you speak or type in the chat?
Theo, this was very good. Oh, he typed in the chat. He said hi in the chat. Hi, Anson. Do we know you from the Discord, or did you find out about us elsewhere? Discord. Okay, cool. What's your handle? Anyway, no, Theo, this was really, really good. Anson Lau. Yeah. Okay, I've seen Anson Lau. Yeah. It's advanced stuff. I'm glad to see that you're out there creating these methods. I guess I'm not sure what to call them, but I'm seeing. I had anticipated things like needing to do the sort of things that you're doing in forwarders. I hadn't. I'm starting to realize now that this is a standard way of getting finer granularity control over contracts that may have lots of consequences associated with their execution.
Mm. Yeah, I mean, I'm expecting that a lot of these patterns will just kind of emerge as people start building them.
Yep.
I've been postponing really learning Rolang until we have enough of these patterns around, enough components, so that we can work at a high level and.
Well, another thing, Jim does so many things that I can't imagine when he would even have time to try to learn Rolang. But yeah, I spend most of my time trying to learn it, and this is as far as I've got. So I'm glad to see someone really go to work with it and give us some things we can start to emulate and build on.
Great. Well, look forward to having many more of these discussions in the future, and on my part, making some cleaner patterns.
Well, thank you so much for this. I mean, it's a special thing, and I think that having this recording is going to help a lot of people and show.
David, you missed a good one. You'll definitely want to catch this one on video.
I was thinking it's just starting.
I almost missed it, but I got in just as they were starting.
Oh, but it was supposed. Oh, okay. The time isn't it supposed to be 2 p.m. GMT? That's 10 a.m. New York time.
No, that was my mistake. Okay, and it was corrected very quickly by Theo. The right time was 9 o'clock.
Oh, yeah, sorry guys, I'd love to stay, but I've got to head out for the afternoon. But great talking, and thank you for all the joining beforehand as well. And David, happy to go over this stuff if you have questions as well.
Okay, there's a recording, right? It was recorded from the beginning. Okay, no problem.
Okay.
All right.
Yep.
Bye.